everyone. In today's video, we are going to cover translations. Our learning targets for today are I can find the coordinates of a translated figure and I can use coordinates to translate a figure. Now looking at transformations. A transformation is an operation that maps an original figure, which we call the pre-image, onto a new figure, which we call the image. So on my graph to the left, I have triangle ABC, that's my pre-image, and then triangle A prime, B prime, C prime, that's my image. Now those little apostrophe marks are read as prime marks. We use those to denote the figure after we make a transformation. Now a transformation can change the position, the orientation, or the size of a figure. Now certain transformations are called rigid motions. So a rigid motion is a transformation that preserves the size and the shape of a figure. We have three examples of rigid motions, which are translations, rotations, and reflections. Our only non-rigid motion is a dilation. Now, when we make a translation, we want to think of a translation as a slide. So we can either vertically or horizontally slide the figure. Now, when we make translations, we have coordinate notation. So I change my XY coordinates to X plus H and Y plus K. Now the H stands for the horizontal shift and the K stands for the vertical shift. So if I'm adding to my X value, I'm moving to the right. If I'm subtracting, I'm moving to the left. If I'm adding to my Y value, I'm moving up. And if I subtract from my Y value, I'm moving down. So looking at number 1, I have rectangle QRST with the following vertices. I want to move it according to XY, X plus 5, Y plus 7. So when I look at this, I have X plus 5, which tells me to move it to the right 5, and Y plus 7, which moves up 7. So if I take my rectangle, I'd move it 5 units right, 7 units up. So there is my figure after a translation, 5 units right, 7 units up. Now I would label my coordinates. So I'd have Q prime, I'd have R prime, I'd have S prime, and I'd have T prime. And then my coordinates would now be adding 5 and adding 7 to both my X and my Y. So Q prime would be -1, 6, R prime would be 2, 8, S prime would be 6, 2, and T prime would be 3, 0. Looking at number 2, I have triangle CDE with the following vertices. I want to move my coordinates XY to X minus 3, Y plus 8. So again, the minus 3 tells me move left 3. The plus 8 means move up 8. So if I take my triangle, I move each coordinate left 3 and then up 8. This would be my new figure after a translation left 3 and up 8. I would then label my coordinates C prime, D prime, E prime, and then list my coordinates. So I have C prime of -1, 7, D prime of 4, 4, and E prime of 1, 2. Now I can also make translations with vectors. So a vector is a quantity with both direction and magnitude or size. So in my figure to the left, I have vector PQ. So a vector is represented in the coordinate plane by an arrow drawn from a initial point, which my initial point is P, to my terminal point, which was Q. So the vector is denoted as PQ, read as vector PQ. So the component form of the vector is written as PQ with an arrow on the top is equal to A comma B, where A is the horizontal component, left and right, and B is the vertical component, up and down. So my component form of the vector is vector PQ is 4 comma 7. And remember, I should have an arrow above my vector. Now looking at number 5, I have vector WV is equal to 9 units right, 3 units up. Looking at number 6, I have vector BA is equal to 5 units left, 1 unit up. And looking at number 7, I have vector SR is equal to 2 left and 11 down. Now, translating with vectors, I can move my coordinates based on what my vector tells me to do. So looking at number 11, I have triangle STU with the following vertices. I want to move it based on the vector -1, -5. So -1 would tell me left 1, and then -5 would tell me down 5. So if I take triangle, move it left 1 and then down 5, I would have triangle S prime U prime T prime with the following coordinates of S prime of -5, -3, T prime of 4, -6, and U prime of -3, -7. Then looking at 12, I have trapezoid ABCD with the following vertices. I want to move it 4 to the right and then down 1. So if I count 4 spaces right, then down 1, again, I'll label each of my coordinates. So I have D prime, A prime, B prime, and C prime. And then listing out my coordinates, I have A prime of 1, 5, B prime of 4, 6, C prime of 5, 3, and D prime of -1, 1. Now, identifying and writing rules, I can write my coordinate notation or my vector to represent my rule. So I want to go from my pre-image to my image. So in 15, I'm going to go from triangle DEF to triangle D prime E prime F prime. So if I write it in coordinate notation, I have XY changes to X. I'm moving to the right 7 units, so I'm going to add 7, and then I'm moving up 4 units. So I'd have X plus 7, Y plus 4. Now if I have it in vector notation, I would have 7 comma 4. Looking at number 16, again, I'm going from triangle PMNO to triangle P prime M prime N prime N pro. Now looking at number 16, I'm going from triangle PMNO to triangle P prime M prime N prime O prime. So I would have my coordinate notation X comma Y. If I notice, P is moving 4 to the left and 2 up. So I would have X minus 4 and then Y plus 2. And then in vector notation, this would be -4 comma 2. In this lesson, we learned a translation is a vertical or horizontal slide of a figure. Coordinate notation is xy changes to x plus h, y plus k, where h represents a horizontal shift and k represents a vertical shift. A vector is another way to make a translation and is represented by a comma b, where a represents a horizontal shift and b represents a vertical shift. That's a wrap on this video. We'll see you in the next one.